Welcome to the very next module. This whole module is going to be dedicated to setting up a Mongo service that we can use to run MongoDB locally on our dev machine. To start off with, the first lesson here will just be a quick overview of what the objectives are for this module. By the end of the next few lessons, what we are aiming to achieve here is we want to configure a database service within our Docker Compose file. And then once that's set up, we're going to download and use a tool called MongoDB Compass, which will be a graphical user interface that we can use to explore our local instance of MongoDB. The MongoDB service that we're going to be running, we want to make sure that we implemented some kind of local authentication for that Mongo database. As well as we want to set up and make use of a volume for the Mongo service in order to persist data locally across container lifecycles. So those are the objectives, quite clear and straightforward. In the next lesson, we're going to get started working on this and putting the work into to get it all working. So I'll see you in the next lesson. Cheers for now. The first step to get our Mongo service up and running is to add a new additional service to our Docker Compose file. And in the last module, we left off by creating and migrating all our Docker configuration to Docker Compose. However, we only implemented the one service there, which was called API. And so let's go ahead now and add an additional service into the configuration here in our Docker Compose file. So under the services key, I'm just going to give us some more space. And above the API service, let's go ahead and define a new service, and we're going to call this Mongo. So we can just say Mongo : and the first key here that we want to set up is the container name, and we're just going to go ahead and call this myappdb. And so you can name this whatever you want, but just make sure that you name it consistently and then use that name consistently whenever you're referencing it. The next key that we need to set up here in our Mongo service is the build, and this is going to be a reference to the image that we want to set up. And so with our API image, we had a Docker file that we defined in our API folder, and so we could just reference that locally. With the Mongo service, we want to actually make use of a public Docker image. Let's just go ahead and head on over to Docker Hub quickly. So you can head on over to hub.docker.com/_/Mongo. And once you enter that URL into your browser, you'll see that you land on the Docker official image for Mongo. This is an image that we can make use of and reference. You can go ahead and read all the documentation and some of the other notes that they have here. So yeah, this is available to us publicly, like I said, and there's a whole lot of different tags which you can go and see which one is the latest one. All we need to do in order to pull and build this Mongo image from the public Docker Hub repo is we can just say Mongo and then latest, and then Docker Compose is going to know that it must pull the Mongo image from the Docker Hub public repository. So once we have the container name, the next key that we want to set up is which image we want to reference for our Mongo service. Previously, with the API service that we've set up, we use this build key instead of an image, because the way that we were building our image here is with a specified Docker folder which we set up and which is housed in the API folder. And with the Mongo service, we want to be doing things slightly differently. And the reason is that we want to reference a public Docker image that's available to us through Docker Hub. If you open up a new browser and go ahead to hub.docker.com and then /_/Mongo, you'll see that you'll land on this page that says Mongo, and you'll see this tag here that says Docker official image. You can just see how much downloads and stars they have on there. So this is a well-maintained and quite stable image that's available to us. You can go ahead and take a look at the documentation and read through any of the notes here. There's also a tab for the tags, which just specify the latest versions that it's using. So this is the official Docker Hub image that we can make use of. And so the way that we set that up is we use this image key over here, and then we can just reference the Mongo. We can just reference the Mongo image, and we can specify the latest tag, and that will just pull down the latest Docker image that's available to us there on Docker. Docker Compose is going to be clever enough to detect that with this syntax that we set up, that it must pull this Docker image, which we specified is the Mongo one, from the official Docker Hub repo. The next key here is just a little bit of configuration, and it's just this restart key, and we're going to set this to unless stopped. So this whole Mongo service will only ever restart unless we forcefully stop the container. And the next one for now is we just want to set up the ports. The convention with Mongo is to use the port 27017, and the same way that we've mapped port 3000 for our Express API, we're just going to create a mapping which will map our localhost port 27017 to a port 27017 within the container, and that way we can access the MongoDB instance from our localhost without having to gain access inside the container. Alright, so that's all the configuration that we need to set up a very bare bones version of our Mongo service. So I'm just going to clean this up a little bit and delete that space. And I think with that configuration, let's just go ahead into our terminal here and make sure you're at the same level as your Docker Compose file. Within there, let's just run a Docker Compose up. When we hit enter here, what's going to happen is we've recently added this Mongo service. What's going to happen here is the new service that we've declared Mongo service, it's going to pull the image from the public Docker Hub repo. And the image is quite large, so it is going to take quite a while. And then it's going to rebuild or just use the same image that we have for our API service. And then once those images are built and ready to use, the containers will be spun up. So we can just watch what happens here in our terminal. So I'm going to hit enter. As I mentioned, this is going to take quite a while. Once the image has been pulled and downloaded, our containers will be spun up, and then you'll see there's a whole lot of console logs that have been dumped out into terminal. I'm just going to increase the size of the window here so we can just take a quick look, and you'll take note that once everything's been pulled and you'll see the container API was created and this new container MyAppDB has been created, and both of them have been attached to the network here, and you'll see Docker Compose then references any console logs that are coming from the MyAppDB container here in yellow. So you can see all of the information here related to the Mongo service has been printed out, and you can just take a quick look here. The API, which is the other container, has been successfully started, and the way we can see that is down here. We've got our server listening on port 2000. It's just the way and the timing of the different services when the different consoles logs are printed out, and that's why it's kind of in this order. That's what we should see in our terminal. Within the Docker desktop app, there's a cleaner version of the logs. If we take a quick moment to just go through some of them and take note of a few things here. There's a whole lot of information here that's not very useful to us. Specifically, there was one output in this log that I wanted to take a quick look at. And if we take a look at this one, you'll see that it references here access control is not enabled for the database. The reason being is that our configuration that we set up for Docker Compose is quite lightweight at this point in time. It's literally just a bare bones Mongo service. So we haven't even added authentication or access control at this point in time. So that's something that we'll implement quite shortly. And the second bit of information I just wanted to point out right now is these two logs here. You can see that there's some information that has been printed out saying that there's a listener set up and it's waiting for connections, and that's available on port 27017. If you see this, you can kind of assume that the Mongo service is now waiting and listening on that port. And so from our localhost, then we can connect to that specific port and then start interacting with the Mongo service. So I think we'll do that in the next lesson. For now, let's take a quick break. We've done the setup to get our bare bones service up and running, so we'll start doing the work to connecting to it on our local host in the next lesson. So I'll see you in the next lesson. Cheers for now. At the end of the last lesson, we spun up our Docker containers using Docker Compose, and we have a Mongo service that's ready and waiting and listening on port 27017. So let's figure out how we're going to go and connect to this and take a look at what that's all about. If you open up a new browser and you can just search for MongoDB Compass, it should be the first item that's listed there, and you'll land on the website here for Compass. And Mongo Compass is just a graphical user interface that we can use for MongoDB. So instead of interacting with the database via the terminal, it's just a nice clean way for connecting to the database and playing around with all the features. I think this is quite a useful tool to use in your local dev environment. and will be very useful also just for our demonstrations here. So to download Mongo Compass, quite simple. You just find the download button on the website. Once you navigate to the download section, you can just go ahead and read through anything that you need to, but more specifically, you can go ahead and just choose a version that you want to download, your specific platform that you're working on, and the package. You can go ahead and download that. Once you've downloaded the package, you can just double click on it, install it, and then you should have Compass working locally. Once you have installed MongoDB Compass and you've opened it for the first, it should open up and you should see something like this where it's offering you to a new connection of some sort. On my local machine, I still have our MongoDB service up and running, that my app DB container, and it's waiting and listening for connections. So we also pointed out in the last lesson that there is no authentication set up. So at this point in time, we can make a very, very simple connection to MongoDB here. You can just use the standard default here and you can click on connect, and you'll see upon clicking on this, there'll be some activity in your logs for MongoDB. Compass will now open up a section to interact with the specific instance of MongoDB. The Mongo instance that we're running is going to be empty. And so if we take a look at the local tab over here and we look in the startup log here, this is just going to contain some information related to MongoDB starting up. So you can take a look in here out of interest, but it's really not anything important you need to know. You can just take a look at this out of interest. We have successfully established a connection to our MongoDB instance via the MongoDB Compass application that we've just downloaded. Our Mongo service is starting to take shape. Let's take a short break here. In the next lesson, we'll start working on implementing the authentication and configuring the Mongo service to enforce authentication. And so we'll do that in the next lesson. I'll see you on over there. Cheers for now. We've reached a point where it's time to set up authentication within our Mongo service. So we're going to get started straight away. There's a couple of different ways to do this. You might see, and in some of the documentation, you can make use of this environment key, which will be environment variables that you can inject into the container. And you can just list the name and values in here. There is an alternative way to do this, and the way that we're going to use here is we're going to make use of this env file key, and then we're going to set up and reference a brand new .env file that we're going to set up. So I'm just going to type in here env.development, and I'm going to hit save there. We haven't set this up yet, so that you don't get confused. And just as a reminder, we already have a .env development file which is housed within the API folder. That file is going to contain all the environment variables for our API folder. For this Docker Compose Mongo service that we're creating here, we're going to have to create a new file. So we can just go ahead and add that in here. We'll say .env.development. And this is going to contain any information that is going to be specific to environment variables that we want to inject into the Mongo service that we've created here. So you can just think of this .env file as one that is specific for our Docker Compose configurations. So just make a comment here and we'll say MongoDB config. First key that we're going to create here is Mongo URI. The value of that is going to be MongoDB : // and we'll just say localhost : 27017. The next key will be Mongo, and then it'll be initdb database. And this is going to be the name of the database, and we're just going to call this myappdb. The next key here will be initdb root username, and this will just be a username that's defined for the root admin of your local Mongo instance. You can call this whatever you want. I'm just going to say Jack, and then the last one will be Mongo initdb, and we'll say root password, and then you can put in any password here. This is just for local authentication, but it's just so that we have a username and password set up. Once we've defined these key values of our environment variables here in our .env development file, it'll now be available to this Mongo service. And so when we rerun the container, it's going to inject those variables into the Mongo service, and then Mongo is going to pick up that we have enabled security now on this Mongo service because we've defined these environment variables for the initdb, which was the database name, the root username, and the root password. So it automatically will infer from that context of those variables that we provided that we want to be setting up authentication using a username and password. To test this out, we can just go ahead and we're going to kill our previous instances of the containers that we were running. And once that's done, I'm just going to give us some more space here. So now that the containers are stopped, go back to Docker Desktop and delete the node Docker Mongo containers. So you can just go ahead and delete those containers. And then you can just rerun Docker Compose up. Now that we have it rerunning, you can just do a search in your terminal for this keyword authorization. And you'll see that we have this log here that says that authorization is now enabled. So now that this is set up, let's try and create a connection to our Mongo service now. And so previously we just click connect here with all the defaults. All that we need to do now is go to the advanced options and leave everything as it is for the general tab. Under authentication and authentication method, make sure you have username and password set up. And then you can just implement the username and password that we set up in our Docker Compose file with the environment variables. So you can go ahead and just insert those values. And once you have that, you can just go ahead and try and click connect. If you've made a successful connection, you'll see we get access to the database now, and we can take a look at the startup log, and you'll see all the information in there. And there is one thing that you can do here. You can just go ahead and save this as a favorite, and we can say my app DB, and then this will just save that information so that we don't have to re-enter it every time we want to connect. Everything is looking good now for authentication. We've successfully set that up. We've wired that up to Docker Compose, and we've tested out in MongoDB Compass, so everything's looking good to me. Let's take a break here. In the next lesson, we're going to turn our attention to setting up persistent storage, and we'll do that using volumes. So we'll cover that in the next lesson. I'll see you on over there. Cheers for now. Picking up right from where we left off in the last lesson, where we've successfully authenticated our database, or set up authentication rather, and now we have got access to our MyAppDB through MongoDB Compass. I wanted to demonstrate a problem that we have with our setup. The problem that we're going to have is whatever we save to the database will be saved while our container is running. But if the container stops and is deleted for whatever reason, any information that is saved to the database during that container's lifecycle will disappear forever. We want to solve this problem using volumes, but just to kind of test it out, we can head on over to this local tab over here, and you can just click on this plus button, and we're going to create a test collection here. So we'll just say test, and you can create the collection. You can just go and add some data in here if you wanted to. And we'll just add something in here just for testing purposes, and you can insert that document. Once you've done that, you'll see that we have a collection test with one document in it now. So what I'm going to do is head on over to our terminal. You can just hit Control-C to stop the containers. And once that's done, within Docker Desktop, I'm going to delete the container. We'll say delete forever. And then we can just go ahead and rerun Docker Compose up. Once the MongoDB server is up and running, I'm just going to refresh this database, and you'll see as soon as I refresh the whole database, we've lost that test collection with any documents that were in it. So that just proves to us now that our data within the database is not being persisted across container life cycles. So we covered volumes in quite a bit of detail in the previous modules. So now that we have that knowledge, we can just go ahead and set this up, and it's going to be quite an easy fix for us at this point in time. So if we head on over to Visual Studio Code, and you can go to dockercompose.yaml, the way we're going to do this is set up an additional config key here for volumes, just like we did in our Express API. And we're going to create a volume mount here that we can use. So I'm going to reference a new folder, which we're going to create in a moment. So it's going to be a folder at the root of our whole project. And then I'm going to say :/data/db. And this is a reference to a folder and a subdirectory within it called db, and this is going to be contained within the Mongo service container that is created. So by creating this mounting, we taking all the information that is created in this db folder, and we storing it in the data folder that we're creating here locally. So you can just make sure that you've saved your work, And once you've done that and you have your data folder that you've created, go ahead and kill your containers. I've already done that. And so you can rerun the containers now, which with this new volume that's been set up. So we'll say docker compose up. Once the container has been rerun, you'll see that the data folder within your project now has been populated with a whole lot of files and folders. If you head on over to the Docker desktop app to your MyAppDB container, you'll see under the file section here, there's this data.db, and you'll see that there's a mount that has been created here. And all of these files and folders that we see here have now been mounted to this data folder. So what this allows us to do is persist our data locally. So if we head on over to MongoDB Compass and we create a test collection, you can go ahead and just insert a document. You can put whatever random information you want in here and insert that, and then you'll see now we have a test collection with one document. And if I go ahead and kill our containers, and once they have been stopped, you can just go ahead and delete the containers here, and once there's no containers, we can restart our containers and just go ahead, and if we refresh our MongoDB instance, you'll see that the test collection has stayed here. It's persisted across a brand new container lifecycle. And so with that, we've successfully implemented persistent storage using volumes, and that's all looking good. So let's take a quick break here. So well done on making it this far. It's been really good work up until this point. I'll see you in the next module where we'll crack on with our API. So I'll see you over there. Cheers for now. Welcome to Module 7, where we're going to be abstracting the router in our Express API. In the last module, we did the work to set up a Mongo service using Docker Compose. With that work that we finished in the last module, we can start shifting gears slightly and start heading back over to our Node Express API, start doing a little bit more work and writing some code to start moving our API forward and progress it to a point where we can start to be fully functioning and getting it to the point where we had in mind in the beginning of this project. In terms of what we want to try and achieve in this specific module, as I mentioned, we're going to be working back in our API, our Node Express server. So the high level goal for this module is to make sure that we have abstracted our Express router. So the specific things that we want to get done here, we want to remove that ping route from the server.js file that we just used to test our Docker setup. And then we want to begin creating a more extensible, more manageable Express router that is abstracted from that server.js file. And there's two new things we want to introduce into our configuration. That the first one being an API prefix so we can make use of, as well as the ability to define and toggle different high-level API routes on and off just using a simple JavaScript boolean. And then at the end of the module, we want to set up a set of default routes that we can use in our API as a foundation to have a test route and some 405 and 404 methods to catch any traffic that doesn't find any of the other specific routes that we create down the line. So the objectives here are pretty clear, pretty simple stuff in terms of what we want to achieve. However, in order to set this up, it is going to be a bit of a process, so we'll just take one step at a time, and I'm just going to explain it in detail and quite clearly exactly how we're going to approach this. So I'll see you in the next lesson. Cheers for now. Before we dive in and start writing the code to implement our abstracted Express router, I just wanted to take a moment to outline exactly how we want our router to work. So we can take a look at a high-level design of what we want that router to look like, and then we'll just cover 2 or 3 important points about some of the design choices that we're choosing, and I'll go through some of the reasons why I want to set it up this way. And I'm hoping that this will provide some clarity for when we start writing the code, as it's going to be another one of those iterative processes to get to the end goal. And I think just going through this right before we start writing the code will just help you make a bit more sense of what we're actually trying to do here. In one of the previous modules, we set up an initial ping route and we just wrote that in the server.js file. But the problem that we're going to face here is that as our API gets more and more complex, the number of routes that we have in our API is going to increase. And so if we have all of these routes sitting in our server.js file, it's going to end up polluting that file, and it's just going to become really hard to maintain and hard to read, as well as just that file's just going to get big and clunky and ugly. And so what we want to do is set up our code base in a way that's easier to read and manage. And the way we're going to do this is by abstracting the Express router as well as the configuration around the router, and we're going to modularize and encapsulate a high-level group of API routes, and so that they can be separated into their own files in a very neat and tidy way. If we take a look look at our Express router design just from a more conceptual point of view, we have this lib folder that we've written already in our code base. It's got that config.js, the server.js, and then the setup. And then so what we want to do now is take any of the routes that we had in that server.js, which was just that test ping route for now, and we want to create a folder within our API source code that is going to house all the routes for our API. So yeah, we will create that folder which will group all the high level API routes together, and each root group that we have in our API will have a dedicated file to it so that we can logically organize and define each route that we have within our API, and it can belong to a specific. So for example, we'll have this default.js file which will contain all the API routes like 404 not found or 405 method not allowed, and maybe a ping route or a test route, something like that. Later on down the line, we might have a user.js file where we can put all the routes around getting a user, deleting a user, posting a user, and we can just group it in that fashion. So it'll all make a lot more sense when we start writing the code. The key idea here is that we want to create this index.js file where we can then export all the routes in one go, and we can use some conditional logic, and together with this config mechanism that we've created, we can then have the ability to turn on and off whole sets of root groups. And let's say for whatever reason we want to turn off the whole of the user API route, we can just disable it in our config, and then we won't be able to access that user because of the way we'll set this up in that index.js within that routes folder. And then lastly, we'll set up a setup routes function, which will set up the Express router and inject all the routes that we've created. And then it'll just allow this setup routes function to be exported, which we can then import in our server.js file. And then at the end of the day, the end goal of making this a lot neater and more abstracted is going to be achieved, because instead of having all of our API routes defined in our server.js file, we can just reference this one setup routes function, and it's just going to be a lot neater and a lot more easy to manage. So that's what we're trying to achieve in a nutshell. Let's take a short break here. In the next lesson, we'll start writing the actual code to start. So I'll see you on over there. In the last lesson, we took a brief look at how we want to design our Express router in our API. We went through a few high-level diagrams, and I just explained to you my thinking around how I want to set this up in our project. Now it's time to turn our attention to Visual Studio Code and start writing the actual code to implement our Express router. Up until this point, we've only implemented one single endpoint in our API, and that was the ping endpoint that we were making use of. We set this up for a very simple test that we needed to do when we were trying to sort out our networking in our Docker setup. So let's head on over to Visual Studio Code. Make sure you have a terminal running and that your Docker containers are all set up and ready to go. I've gone ahead and started up my Docker containers before we start writing the code to implement our Express router. Let's do a quick test to test the ping endpoint that we've set up already. And I'm going to go ahead and open up Postman, which is a tool that we can use to make HTTP requests. It's a very common and popular tool that a lot of developers use to test APIs. So in Postman, you can set up a new tab. You can just open a tab up in this section over here, and then you can go ahead and in this URL bar, which is just like a normal browser, you can select the specific HTTP verb that you want to use, and there's a drop-down menu there that you can make use of. And then you can go ahead and put the host path, the port, and the URL path of the API that you want to hit. So in our case, we want to test the HTTP localhost port 3000/ping route. Once you've inputted the URI or the URL, you can go ahead and click the send button. Once we hit send, we get back this 200 OK HTTP status code, as well as our JSON payload in the response with a key called message. We can also see in our terminal, we've got the console log that's coming out, so we know that this is working. Back in Visual Studio Code, I wanted to point out two very specific things. The first one is that we are using this .get method, which is coming from the instance of the Express server that we set up, and we assigned to this variable HTTP server. So on this HTTP server variable, which is actually our instance of Express, we can access any of the methods that are available to us through the Express library. If we pull up the Express.js docs and we take a look at the application, and this application is the instance of Express that we instantiated when we started up our server. If we take a quick look at the sidebar over here, there's a list of all the methods that are available to us on this app instance. The one that we made use of in our code to set up our test, our ping endpoint was this app.get method, but you'll see that there's basically a method for each one of the HTTP verbs that are available to us. So the post, put, the delete, and then the other interesting one here is the app.method, and another one to take a look at is this app.use. So these are all methods that are available to us right off the Express instance, and that is something that we have created in our code here, and we've assigned that to the variable of HTTP server. So we're going to explore some of these methods now that are available to us on the Express instance. Let's go ahead in our server.js file, and we will comment out this block of code that we've written here, and we'll just save our work for now. And I'm going to go ahead and give us some more space to work with here. With the ping route commented out now, our API has no routes to match. So if we did make a request to the server right now, we'll just get back Express's generic 404 error. And just to prove that to you in Postman here, we'll just do a quick GET request. So I'm just going to go hit send here on our ping endpoint, and you'll see that we get back this 404 method not found. And you'll see that the response that we get back is actually HTML. And that just, whenever you see these HTML errors, you'll know that this specific error that you get is the error that is coming back from the Express library. Let's go and set up a few things here. The first method I wanted to test out here was this .use method, which is available to us. And you can see in the documentation, the .use method allows us to mount specific middleware and match them to a specific path. So the arguments that it takes in is a path and a callback. I think the best way to explain this is to demonstrate it. So we'll just say .use method for handling all incoming requests. And so we can do that by saying HTTP server, and we'll reference that .use function. And remember, it takes in a path as well as a callback, but we're going to leave out the path for now, and we're just going to insert an arrow function here. The Express library and all these callbacks that we send in as middleware, we've got the request, the response, and as well as a next function, which is a callback that we can use to just send the request onto the next request handler in the chain. And so all I'm going to do for now is we'll do a simple console log, and I'm just going to give this a number so that we can start seeing in what order these are being executed in. I'll just say first express middleware function. And then for now, we'll just invoke the next function, even though as of right now, we don't have any request handler that it can pass it on to, but we'll just set this up for one moment. All right, once you've saved that work, let's head on back over to Postman. Once we're in Postman, it doesn't matter what we put in the path because this app.use should be executed on every incoming request. So I'm just going to delete the ping, and we're just going to have the base. We're just going to have the host as well as the port here, and then I'm just going to hit send. And as I hit send here, you'll see that we get a 404 not found. And that's because we don't have any endpoints in our API. But the interesting thing is, as you can see in our terminal, we've got our console log here, which says our first express middleware function has been hit. So every time we send a request, you'll see that console log is being hit because this function that we've set up here that uses this .use is just going to execute this request handler on every single request that comes through. The second thing I wanted to demonstrate here is we can use the .use function also to match a request handler to a specific path. So we can say we'll set up a .use here for handling any requests that start with API. Going to fix this spelling mistake here. And so we can set that up really quickly. We'll say HTTP server. We'll reference the .use function. And the first argument it takes in here, and this is what we want to set up, is a path. So if you just use a simple // it's just going to be a reference to the base path. So that's any path that you put in for HTTP localhost 3000. But in our case, let's test something specific so that it can match to something specific that we're looking for. And let's go ahead and set up this path called API. So it'll be /API and strings. And then we'll just set up our request handler with an arrow function. And the arguments that go in here are the request, the response, and then we'll just make use of this next callback. And in the body of this function, we can go ahead and set up a console log. And I'm just going to reference this as the second kind of item in our middleware chain that I want to log out here. So we'll say second express middleware function. And then I'll go ahead and just invoke this next function, even though we've got nothing that we're sending this on to. So go ahead and save your work. Back in Postman, we can pick up where we left off. We were just hitting the localhost port 3000. I'm going to hit ascend here, and you're going to see we do hit that first console log. So that's the first piece of express middleware that we've set up in our chain, which we're hitting. But you'll see that we're not hitting the second one, and that's because we haven't matched to that API route. And so let's go ahead and do that. I'm going to reference the / API route in our API. Then I'm going to go ahead and send, and you'll see we get another 404 not found. But you'll see in the terminal output that we have here, we see the number 1 and that first middleware function is getting hit because it's always going to be hit. And we see that second console log, which displays the output second express middleware function has been hit. For now, we've just been getting these 404 HTTP status code, and let's go ahead and uncomment out this HTTP server.get. So for every request that's going to come through, it's going to flow through this middleware chain that we've set up in our server.js file. Every request that's going to come through is going to hit this first request handler, which has the console log numbered 1. The second console log that's numbered 2 will only ever be hit if we hit anything with the base path of API. And then this last HTTP server.get, this is matching to a specific method, HTTP method, so it'll only ever be hit if we do a GET request, as well as we send a path to the /ping method. So let's go ahead and test that in Postman. And once we're in Postman, we can just run through the different scenarios. We've got just the base host and the port. We're going to send that. We get a 404, but we hit that first piece of middleware. We're going to reference the /API, which now we should hit the first and the second console logs, and you can see that we hit number 1 and 2. The last one here is let's reference the ping endpoint, which we've now uncommented out, and now in this case we should hit number 1 because that'll run on every request that comes through, and then the second console log won't be printed out, but the third one will be. Or there is no third one, but the console log within the request handler of the ping function body then will be executed. So if we go ahead and send, you can see we get back this status code 200OK, and we've got the message that's coming back, as well as in our terminal you'll see that we get the console log that is related to the ping route. We've been referencing these .next functions in both of the .use methods that we've set up. What's really happening here is when the request comes into this first HTTP server.use, it runs the console log, then it invokes this next function, and then if the request matches to API, it'll hit the function body, it'll hit the console log and invoke the next one. That next function will just invoke the next middleware. This part with the API and the request handler will never pass the request onto another endpoint unless we set it up in a specific way. So we can do this by, in the HTTP server.get, we can reference /API /ping. And so we're just kind of making a nested route here. So if you hit the API path, it's going to hit console log 1 first, it's going to hit the second console log, and then it's going to pass on to the next function. And if we reference the API /ping in the request, it's going to then hit this third one, and that should all happen in succession. So I'm going to go ahead and save my work, and we can test this out in Postman. Once we're in there, we can just send a request to this ping, and you'll see we get a 404 not found because we've changed the path of the route. And so we can just say /API /ping. We can go ahead and hit send, and you'll see that in our terminal, first of all, we hit all 3 console logs. So we're hitting all 3 pieces of the middleware in the chain that we set up, as well as we get the response that we expect with the 200OK, as well as that JSON payload. The last thing I wanted to demonstrate here was one more method that we can make use of. So we'll reference the express instance, which is the HTTP server, and then we're going to add on a .all method. And this is going to act as a catch-all block for any type of HTTP verb that we send through. And then in the first argument here for the path, I'm just going to reference this star or the wildcard character. And that's basically saying for any route, no matter what you insert there, match it to this request handler that we'll set up right now. So we'll just say request and response. And in the function body here, we'll set up another console log. And I'm just going to write here number 4, and we'll say, and then I'll just send back our own response here. We'll say res.status is 404. We'll send back some JSON. We'll say message, and then we'll just set up a string here, and we'll inject the request.url, and we'll say not found. And go ahead and save that work. So what I want to demonstrate here is that the way that the express middleware chain works is that when you send in an API path for like /API, for example, it's going to run through all of this middleware sequentially, and it's going to try and match itself to any path that you send in here. So when the request first comes in, it's going to go to this first piece of middleware. There is no path that's specified there, so it's going to execute this function block regardless, and then it runs to the second one, and then it'll match with the /API, so it'll execute that second block, and then it'll run through to the third block over here. It's going to match to the /API, and then it's going to execute that function block. And then because we send in a res.status, we've ended the request response cycle, then we've kind of exited out of the middleware chain, and we will never hit this last function here, the http.all function, because we've already ended the response. If we send in a path that is not defined or registered within our middleware chain, it's just going to hit this first block here. It's going to write out that console log. It's going to skip the second one because it doesn't match the path. It's going to skip the third one because it doesn't match the path, and then it's going to hit this last HTTP server.all, and this is for any HTTP verb that sends through. So whether it's a put, a get, a delete, anything, it's going to then match the wildcard, and that's for anything that we send through. And then we're just going to hit this console log that says for catch all, and then we'll have a response.status that says 404, and it'll send back through the JSON payload. And so in this way, we can set up a catch all response. By sending back the response, we end the request response cycle, and you'll also notice that we'll never get back that standard express HTML error that we were seeing. We should always get our own formatted 404 error here. So let's go ahead and test this in Postman to get an idea about what I'm talking about. So once we're in Postman, we can run through these tests. Let's go ahead and just test out a call to a GET request to the /API path, and you'll see, so we hit that first middleware function, we hit the second one, it passes it on to the next. Because after the API we haven't specified anything, it passes on to the next middleware chain, and it doesn't match the API/ping endpoint, and so then it hits our fourth piece of middleware in the chain, which is API not found, and we get that 404. But if we go ahead and say API/ping, and I hit send, you'll see that we hit the first middleware function, the second one, and then the ping middleware sends back its response, which is a 200, and it ends the request response cycle, and so we never hit that fourth piece of middleware that we've set up. And the last test is just to send through anything here. So if we just send a request to a localhost 3000 and I hit send here, we're going to get a 404 not found. But in the terminal logs, you'll see that we just hit that first one, which runs on every request, and then we just hit the fourth one. So we've skipped all the other middleware because none of the routes match what we send through. So if we send through anything here, even if it's like user/API/ and pass through an ID, whatever, it's just, if we hit send, we're just going to hit that first middleware and always catch on the last one. And so that just demonstrates a little bit how the Express middleware works. And this was just a demonstration just to make sure that you have a solid understanding of how the Express middleware chain works and how we can use paths and these strings to match an incoming request to specific route handlers, as well as the different methods that are available to us to create these combinations to match incoming requests to specific request handlers, which will do specific work on that request. So the key points here is that the Express instance that we instantiate have these methods available to us. It's got the .use method, as well as the .get, put, delete, all, and these will all match to specific HTTP verbs, or I'll catch all of them. And then each part that we define as the first argument into any of these methods is going to will be registered, and then it can be matched to an incoming request, and then it'll then pair that with a request handler that we set up for each one of the paths. The third point, which is really, really essential to understand, is that this Express middleware chain that we set up runs sequentially. So we've demonstrated that by numbering our console logs, and we can see that if the criteria match everything that we set up in our routing sequence, it's going to hit every function block in there, and we can pass control from one request handler to the next. And this happens in a sequential fashion, unless the incoming API path that we send through doesn't match specific criteria that we define in the first argument of any of these methods. So that's really important. So even though they run sequentially, we can skip certain request handlers based on how we set up the criteria of how the paths match to the request handler. And the last point is this .all. The .all method with a wildcard character in the path, we can use this as a catch-all. And if we place that at the bottom of our middleware sequence, we'll make sure that if nothing ever matches like upstream of this function, it'll always catch any incoming request, and it'll end the request response cycle with this method 404, or the HTTP status code 404 that we set up here, which means that the route or the path in the API that you send through has not been found. We've run through everything that I wanted to demonstrate here. We took our time, we went through this nice and slowly just to understand exactly what's available to us on the Express instance in terms of setting up routing. So let's take a short break here. In the next lesson, we're going to take a look at the Express router class that is available to us, and we'll see that how we can do the exact same thing that we've just done here with the router class that is available to us in the Express library. So well done on making it this far. All of this stuff will make a lot of sense we're building up a lot of foundational knowledge. So I'll see you in the next lesson. Cheers for now. In that last lesson, we started diving into some of the methods that are available to us on the Express instance, played around and just took a look under the hood how the Express middle chain kind of flows. In this next lesson, we're going to dedicate to exploring a class that is available to us in the Express library, and this is the router class. If we take a look at the documentation real quickly, you can see that this router is an instance of Express that we can set up, and it works in a very, very similar way to the main application or the main Express instance that we set up, except that this router specifically is designed to work with middleware that is related to routing. You can think of the router as a mini application. So this Express instance that we already invoked is an instance of Express, but we can set up another instance that is the router, and this will behave as a mini Express instance in its own right. That allows us to do some really interesting things, and if you look at the documentation, it says the router behaves like middleware itself. And so you can use it as an argument to the app.use, which we've been playing around in the last lesson, as well as you can even send a router into the routers.use method on its own. And so if you take a look at the methods that are available, we have the .all, the router.method, which is all the HTTP verbs, as well as at the bottom here, we've got the router.use. So all those methods that are available to us on the normal Express application that we are playing around with, that are listed here. Some of those specific methods are also available to us on this router object that we can create. And what this means for us specifically is in the lesson where we're now talking through the design of our router, I was talking about modularizing our router in a way that it's got a router for specific high-level API. So if it's a user set of endpoints or a default route, or whether it's an account API, we can have a router that handles and modularizes the code for each one of those. We're going to make use of some of the way that this router is designed to implement our specific way of handling routing in our API. So we're going to go back to Visual Studio Code, and we're going to run through some code examples so that this makes sense. The first thing I'm going to do is I'm just going to remove all the code that we wrote in the last lesson. So I'm just going to delete that out. Everything except for this ping route that we had initially. I'm going to go ahead and save our work. And if we do a quick test in Postman and we send through anything to the API, you'll see we're getting back the base Express server. No matter what we send through here, we've got no console logs either that are being printed out. So basically we've just deleted and removed our whole Express middleware chain. And so now that we've got a clean, fresh slate to start with, we can then start working with our Express router now. So the way that we set up this Express router is we can set up a constant and we'll name it router. And then we can reference the Express library, which we've imported at the top of the file. We'll say express.router, and that's with a capital R. And then we'll just invoke that to the instance of router, then gets assigned to this variable router. Once we have this router variable, we can then reference the different methods that are available to us. Let's start with a first .use. So we'll use a router.use, and then I'm just going to set up a path here that we want to tell our middleware to match to, and I'm just going to reference a single // and this is basically saying whatever request comes into the API on HTTP 3000 / will then run through this next piece of middleware that we set up here. And so we'll just set up our request, our response, as well as the next function. And then we'll do a console log as we did previously. We'll give this a number and we'll name this router middleware function 1. And then let's just go ahead and invoke that next function. And for now, I'm just going to comment out the code for our ping route so that the only middleware function that we have is this router.use. If we go and test this now that we've set it up and we head over to Postman, let's just initiate a request to our API. And if I hit send here, you'll see that we're getting this 404 not found. The error from Express is coming up, but interestingly, and this is what I wanted to point out, is that there is no console log that is being dumped out to the terminal. And there's a very specific reason why, and that is because even though we've instantiated this router, we've attached the use method with our string, which is matching to the // which is just the base path. And so the final step to get this router to actually work is we need to reference our instance of Express. So that'll be HTTP server. And then we need to reference this .use function. And if we remember, the documentation said that we can use this method to mount a router onto the Express instance. So the way that we can do that is we can reference the / here, which is just the path for everything, all incoming requests that are coming in. And then we will just then, instead of passing a request handler, as the document said, the router instance acts as middleware itself. So we can just then reference this router that we've created up here on line 9. and I'm going to go ahead and save my work. And if we initiate a request now to our API on the base path and I hit send, you'll see that we do get that 404, but now we are seeing our console log with that number 1, and we're seeing that the router middleware function is being hit. So just to reiterate there, we've created an instance of router. We've attached a piece of middleware onto the router using the .use method at the base path of the router. And then we've gone ahead and we've attached that router to the base path of the .use method in the HTTP server, which is our express instance. And therefore, any request that comes through to our API is going to get handed off straight to the router that we've passed in here. And then it's going to run through any of the middleware that we define onto that router. But one interesting thing I wanted to demonstrate here is if we uncomment out this code here for the HTTP server.get and we save our work, this get method and the part that we have here and the associated request handler, this has been registered to our express instance and not the router instance. And then let's just go ahead and see how this kind of all works. So if we initiate some request, we'll just initiate to the base path here. We'll see that we just hit our first middleware function, which is attached to our router. If I send something through to /API, you'll see that we still hit that middleware function on the router. If I do a /API /ping and I hit send here, you'll see we get back a 200 with the JSON payload, as well as we don't actually hit our router middleware. We're only hitting the middleware that is related to the middleware that's been registered on the express instance itself. So what's happening in this case is when the request comes through, the middleware that's been registered onto the express instance gets matched first, because that's in the sequence of middleware it's been registered first. And then the router middleware that we've registered is registered after it. So if we go ahead and move this HTTP server.use and we register the router middleware before the middleware that we register on the express instance, you'll see that things will change up slightly here. To test this out, we'll just do a request to API, which should just hit our middleware function on the router. But if we do an API /ping, you'll see that we still get our message back with a 200. But in this case, you'll see that we hit the router middleware first and that console log gets printed out. So what happens in this case is that it runs through the middleware. The middleware for the router is registered before the API /ping. It runs that console log, and then this next function gets invoked and it passes it on to the next piece of middleware that's in the chain, and the next middleware that is in the chain is this .get. It matches it with the API /ping, and then it hits this request handler. But if we did API /ping /test, you'll see that we get a 404 not found. And that's because, and even though we are hitting our router middleware, it's hitting that next callback. It's passing it on to the next middleware where it's trying to match /ping /test. It doesn't find anything. And then so it just errors out with a 404 not found. The last thing I wanted to demonstrate here is if we set up a .all method on the router and we say, set this up in the same way with the wildcard. We'll set up a request handler, and then in here we'll set up a console log. We'll just reference the number 2 and we'll say router middleware catch all. And then lastly, we'll just end this request response cycle with a 404. And then we'll end that off with a JSON payload that we sent through with a message and a string, which we'll pipe through the request.url, and we'll just say not found. And so what's going to happen here is we've registered this .all method onto any path that comes through. And so the middleware chain now looks like this. The first one references this .use. So the router is going to, on every request that comes through, it's going to run this first piece of middleware. The next function is going to be invoked, and then it passes on to the next piece of middleware that's in the chain. It will then match to this entry that we've inserted here, because it's a wildcard is going to match every single path. So then on every path that is incoming, it's going to get matched to this request handler. So it's going to hit it and it's going to send back a 404. And because we've ended the request response cycle, any other middleware that we've defined after this router.all will never actually be hit. So this ping endpoint that we have here, even though we register it on the actual express instance, this is kind of at the bottom of the order here because of this line of code here where we attach the router to express instance. This ping is registered after everything above it, and that means that because we end the request response cycle in this piece of middleware with the wildcard string match, this API ping will never actually be hit. So in Postman, we can just send through a request to the base of our API. You'll see that we get a 404 not found. We hit our first router middleware. We hit the second one, which is in the catch-all. And so whatever we send through here, whether it's like /API, it's just going to do the same thing. And even if we send through a /API/ping, when we hit send there, you'll just see that we keep getting that 404 not found, and we actually never hitting that piece of middleware. If we cut out that ping endpoint and we place it in between the .use and the .all and we save our work, if we try and hit the API/ping endpoint, we will hit this request handler here because it's now registered in the right sequence. So back in Postman, we can just test this out. At the base path, we send through a not found. We hit our first and our second piece of middleware. Even though the API now is registered in between it, the path didn't match. So if we do match the path with API/ping and we send that through, you'll see that we get back a 200. Then we get a straight up match to the API ping request handler, and then it goes and it prints out that message and sends through the response. So that concludes the little demonstration that I wanted to set up for you here. Just trying to show you exactly how this isolated express.router object that we can set up, we can use that to kind of isolate any of the route and the routing that we want to set up in our API, and we can attach it to that router. And the key points are here is that some of the exact same methods that are available to us on the Express instance is also available to us on the router instance. What's interesting is whatever middleware we attach to the router instance, we can mount that onto our Express instance using the express.use, or in our case, the HTTP server.use. And we can just mount the router and just pass all traffic that's coming into our API and send it to that router. The way that we can set up different instances of the router means that we can have a router and route definitions for very specific things in our API. And this is going to be the key to allowing us to build a very modularized routing structure in our code. So well done on making it through all of this. I could have just taken you through the exact code that we're going to be setting up eventually, but I wanted to take the time to just work through this nice and slowly, actually get a feel for how the Express middle chain works, and hopefully you've learned something a bit more about Express itself. And having this good understanding is really going to be a key part to understanding and building really good APIs using Express. So again, well done on making it through all of this. Let's take a short break here. Now that we've covered all this foundation knowledge, we're going to actually start setting up our routing. We're going to add some more files and folders to our API. So we'll set that up in the next lesson. We've taken the time to explore a little bit more in depth how the Express routing works in terms of how it's structured in the library. We got a little bit hands-on. We wrote some code examples with some console logs just to kind of see and reinforce the idea of how the Express middleware chain works and how we can leverage some of those aspects to implement a really well-designed and modularized routing system for our application. In the last two lessons, we've been working in this server.js file, and we've got all of this code that is left over from there. And you can see when I was talking about the design of our server, what I meant by we don't want to really pollute the server.js file. We've just got 2 or 3 route handlers that we've defined in the server.js file, and already the size of this file is starting to grow. And you can imagine if you have 20, 30, 40, 50 endpoints that you have request handlers for, this will soon start becoming very unmanageable. It's not going to be very clean and definitely going to be hard to understand what's going on. So we did do the work here just to kind of make it easier to understand the concepts that we were talking about. But now that we've gone through that, the next step is to start abstracting this router away. Before we remove the actual code here, let's go ahead and set up the folders and the file structure we need. At the root of the lib folder, then we'll just create a file. We're going to call this, that'll be setuproutes.js. And to start off, we're going to start writing some code here. We're going to create a function that we want to export. So I'm going to call this function setuproutes. We're going to assign that to an ES6 arrow function. And for now, let's just put a very simple console log in here. I'll just give this a return character and we'll say testing setup routes function. And this setup routes function is going to act as the entry point that we can reference in other parts of our code base that will just handle all the work of initializing and set up the routes for our Express API. But before we start implementing, let's just go ahead and wire this up to our server.js file. And at the top of the file, we can just say import, and we'll just import that setup routes function. And that'll be from the setup routes file. Then all we need to do To test if it's wired up correctly, we can reference the setup routes function and we can just invoke it. And we can just do that right above our router that we were using in the last lesson. I'm going to go ahead and save my work. We'll see that we get that testing setup routes function console log, and that just validates to us that that has been set up correctly. So now that we have the setup routes function, we can start moving all this work that we've done in the previous lesson and move that out of the server.js file and into the setup routes file. So I'm just going to go ahead and actually remove all of the code that we set up in the last lesson. And I'm just going to delete that out. Your server.js file should look something like this now, very nice and clean. The whole setup of our API routes will come from this one function, which the entry point is in the setup routes.js file. So we'll just adjust the console log a little bit more, just to make it a bit more readable in the terminal. And then we'll see, yes, we get that testing setup routes function, console log is being fired. And so now we can go ahead and start implementing some of our work. Because the setup routes function is going to be doing a lot of work related to initializing our routes for our application, we're going to need the Express library. So we'll go ahead and just import this at the top of the file. We'll say import Express from Express. What I'm going to do now is I'm going to, outside of the body of the function, I'm going to create an instance of Express router, which will act as the high level or the main router for our whole application. So I'm just going to create a constant here. We'll call this router, and we'll reference the Express library and that router class, which we can then just assign to the value of this router here. And now we've got access to a router that we can then start working with. And just to start with very small steps here, all we're going to do is reference the router instance we've just created. We're going to go ahead and use that .use method, and then we'll reference a /. So that's going to be any request that comes through on the base path of our API. And then we'll just go ahead and create a handler for that. And for now, we're just going to work with the request and the response. I'm going to go ahead and put another console log here. I'm going to give it a number 1 because this is kind of the first piece of middleware in our chain now. I'm going to say main router middleware. And then we'll just say, we're not going to invoke or make use of the next callback. We're just going to end the request response cycle right here. And so we'll just say res.sendStatus. And I'm just going to simply send back a 200 for now. We don't have to pass back anything fancy. I'm just going to go ahead and save our work. And so just to walk through what we've done so far, we've imported the setup routes function at the top of our server.js file, and then we just invoke that function. And all that function is doing at the moment is it's printing out a first console log, which is the testing one. The second thing that it's doing is it's grabbing a hold of an instance of the Express router, and it's registering one request handler that we've created here, and it's assigning it to the base path of our API. All that's going to do is log out that one console log, and it's going to send back a 200. The problem here, and we'll test this in a moment, is even though we've registered this middleware in the setup routes function, we haven't attached this middleware to our actual instance of the HTTP server, which is the Express instance. So if we send through a response to anywhere in our API, including the base path, we send through a response, you'll see we just keep getting back the 404 not found. Even though we see this console log of testing setup routes function that's being printed, we know that the setup routes function is being invoked, but the middleware that we set up is not being hit. So we need to figure a way how to attach all of that middleware that we've registered in the setup routes function onto our main instance of our Express application, which in our server.js file is assigned to this HTTP server variable. A very simple solution that we can use here is we can make use of dependency injection, and we can grab a hold of that HTTP server, which is our instance of Express. We can say HTTP server and just pass that in as an argument into the setup routes. I'm going to go ahead and save our work. And then in the setup routes function that we're exporting here, we can then just grab a hold of the instance of Express that is being passed in. And so we can just set up a simple parameter in this function here, and we can kind of rename this or call it what we want. Just remember that what's being passed in here is the instance of Express that's been created when we initialize our Express server. It's named HTTP server in our server.js file, but I just want to rename this to app, and that's going to just conform to the convention of Express. Once we have set up that parameter, we can get access to that Express instance and reference it here by saying app. And then we can make use of the .use method. And remember, this method can be used to mount specific middleware onto the instance of Express. And so I'm going to match this to the path of just one single /. So that's the base path of the whole API. Whatever traffic comes into the base path, we just want to hand that off directly to our router. And that is that router that we've defined at the top of the file. And that router then will have different sets of middleware that is attached to it. And so it'll flow through that middleware pipeline that is created as we build this out. For now, that's the mechanism of how this kind of all works together. We've now attached that router onto our Express instance. And if we go and do some testing now, we'll be able to verify if we have successfully achieved this. If you go ahead and click send there, you'll see you get back a status code 200, and you'll see that we get that console log saying the main router middleware function has been hit. So whatever we pass in here, whether it's a /API, ping, or whatever we decide to pass in. So all the traffic that comes into our Express server is now being routed to this router, which has been set up here. And then whatever middleware that we set up here, we can then guarantee that the traffic is going to flow through that. At this point in our workflow, I want to introduce one small change into our Express API here. At the moment, we've just been kind of working with this base path using the /. I actually want to introduce a prefix into our API routing. So instead of just referencing the /API, I want to create this higher level path here called /API. And that's going to act as like the entry point into our API. So every endpoint from our API going forward needs to start with the prefix /API. Any traffic that comes through to /API will then be passed on to the router. The first piece of middleware is registered with the base. So all that's saying is that any traffic that comes after the API, whatever endpoint it is, it must flow through this piece of middleware that we've defined there. So we can just go ahead and test that real quickly in Postman. You'll see if we adjust our request now to hit the base, we're going to get a 404 not found. And now in order for us to access our API endpoints, we're going to have to start using the /API prefix. And if I hit send here, you'll see we get back that 200. And so anything in our API going forward, whether it's a ping or a user or whatever, the path needs to be prefixed with the API. So that's one small quick change that we can make. The reason why this becomes useful down the line is if you look at the syntax that we're using here, app.use, and then we're attaching this router onto this /API, we basically able to create little mini apps or mini modularized routers and then attach them to different API endpoints. And the reason that this can become quite useful is that we can do things like attaching different versions of our API and assigning them to different modules of routers. So for example, if we had to create a different like modularized router that we say for a different version of our API, so we'll say router v2, and then we'll just create a new instance of the Express router here. And remember, we can just keep on creating these instances of Express router because they're singletons. So every instance of the router that we create can be like a module where we then can just assign methods on. So for this router v2, we can just set this up so we can test this real quick. You can say router v2, and then we'll just use this .all to catch all HTTP status, HTTP methods. And we'll just, on the base path of this router, we'll just set up a very simple request handler. We'll say rec and res there. We'll set up a quick console log, and we'll say v2 API middleware. And then we'll just end this and with a response, and we'll say send status. Let's do something different to what we have up there, and we'll just send back a 500. What we can do is reference this app and then register this whole modularized v2 router, and we can say app.use. And then we can say anything that comes onto the v2 path /API then must get sent through to this v2 router. If I go ahead and save our work here, we can go and test this in Postman. Right, and I've left out the trailing / of our path here. Just remember that's important. So it's a /v2/API. I'm going to save my work. So in Postman, we can just make a request to our API. We get back that 200, as well as we see the console log there, the main router middleware function. However, if we then reference our v2 API and I click send there, you'll see that we get back this 500 internal error. We're hitting the high level router on the base path console log. So now any traffic coming onto the v2 API is going to actually go through onto this v2 router, and then the traffic will flow through the v2 router's middleware chain. So that's just something I wanted to show you and quickly demonstrate. I'm going to delete this code. Now I think you have a solid idea of why we're going to use this API prefix. We've done some initial good work up until this point to start moving our router in the right direction. We've written a bit of code here. We've done some testing. Let's just take a short break here. We'll pick up right where we left off, and we'll continue working on our router. So I'll see you on over there. Cheers for now. The router is starting to take better shape now, and we're starting to head in the right direction. And now we're going to continue doing the work to move towards a very modularized routing system. So to do that, I'm going to go ahead and first just clean this up. I'm going to remove this higher level console log. We don't really need that at this point in time. Let's start writing some code to start seeing how we're going to set up different modularized routing systems in our API. So by now, I think you should be comfortable with the fact that we can just go ahead and instantiate individual routers, and we can create as many as we want. And so in our API, we're going to create a router for every high level set of endpoints. So if we had endpoints for a user service where we update a user, create a user, we'll have a specific router that is dedicated to a whole set of those routes. Let's write the code for this, and it'll start making sense in a moment. So I want to create a constant here. We're going to call this default router. The idea with this default router is it's going to be the router that kind of handles all the generic responses that our API wants to have. So stuff like that ping route, which is just like a health check route, we can add that in our default router. If we need like 4 or 5 method not allowed, or 4 or 4 not found, we can add that to this router where it's kind of the generic maintenance style request and response handling. We'll just instantiate a new router, and that'll be assigned to the value of default router. I'll create another constant here. We'll call this default router, and we'll assign a new express router to that. So we have 3 separate instances of express router in this file right now. The first one here, the high level one, is the main router of our application, and that one's being attached onto our express app instance, which is being injected as a parameter. And so at this point in time, this router only has one piece of middleware that's registered on any traffic that comes after the /API. And so that's this piece of middleware that we've defined here. To demonstrate how we can attach like these sub routers onto the main router, we can just create a few pieces of middleware here. We'll say default router, and we'll just create a simple get here. So we'll use the .get method, and I want to match anything that comes onto the ping route. We'll set up a request handler. Once we have our request and our response available there, we can just set up a simple console log. We'll say default router ping handler. We'll just say res.send status. We'll send back a 200. And let's just go ahead and do the exact same thing for the user router. So we'll say user router.get, and we're just going to use the / to reference anything that comes onto the user endpoint. We will then just set up a request handler. That'll be rec and res. And then we'll set up this console log. We'll say user router, we'll say get user handler. And we'll just send back a res.send status, and that'll be 200. All right, so we've got a default router, a user router with one piece of middleware attached to each one respectively. Now what we can do is I'm going to delete this request handler that we've written out for the main router. So remember, this router is the instance of express router we've instantiated at the top of the class, and this is the router that's being attached to the express instance. We can say anything that comes through at the base path of the router, we want to forward that onto the default router. So now we are attaching this router onto our main router. And then in the same way, we can say router.use. This is where we can define a specific endpoint here, where we say anything that says /API /user, we can just send that off through to the user router. And so in this way, we can just continue setting up mini module for any API paths that we have. So if we had, let's say, an account endpoint, we can send that to an account router. And in this way, we can just, any middleware that's related to each one of these routers, they can then be handled in their own separate files. And then we can just have this high level file where we can see what exactly is being done in our routing middleware sequence. So I'm just going to delete this account one because we don't actually have that. And let's go ahead and test this out and see what that looks like. In Postman, just do a simple GET request to just our base path of our API. And you'll see that we get back a 404 not found. And that's because there is nothing that, there's no middleware in our middleware chain that will match to this path. But if we do an API/ping, this is going to hit our default router, and you can see we get that 200 OK. As well as in our console log, we can see default ping handler has been hit. If we go ahead and hit the API/user, you'll see we get back a 200. And in this case, we hit that user router middleware. And so we can send traffic now to different routers within our app, and they'll be all handled with code that is specific for every modularized router that we create. So we are one step closer to finishing this off in its entirety. Let's take a short break here and pick it up in the next lesson, where we'll start abstracting all the work that we've done for the default router into its own folder and set of files. And so the abstraction of the router is just going to be one step closer to the final product. So well done on making this far. There's a lot going on here, but we're doing good work. I'll see you in the next lesson. Cheers for now. I think we've got a really good understanding of how we can create many routers and many instances of them. We've demonstrated that in the last lesson by setting this up in our setup routes function. We can go ahead and start abstracting all this code that we've written with the individual routers. We can have a specific place in our project structure to house all the stuff related to the route. So let's go ahead and start setting up the folder for this. In our source folder, we can create a new folder. We're going to call this root. And within this root folder, we're going to create a file called index.js. And this file is going to act as a way to aggregate all the different root files that we create. So we're going to have a file for every single high-level router that we have. So the default router, the user router, etc., etc. And so we'll use this file as a way to kind of import them and then allow them to be exported and imported into the setup route file. This will make a lot of sense when we kind of move closer to the finished product. So let's go ahead and create a simple function that we can export. We're going to say export default, and then we'll create an ES6 arrow function that we can export. And as always, let's just go ahead and create a console log just to test that we can wire this up correctly first. So we'll say testing root index.js. I'm going to hit save, and in our setup.root file, at the underneath where we import express, we can go ahead and we can import root, and that'll be from one directory back in the roots folder. We'll import the index.js file. At the top of our function here, we can just call this root function that we're exporting. And if I hit save here, you'll see that we get that testing root index file console log that is printed out. The whole idea with this function is that it's going to return a router that has all the different subrouters that have been attached onto it. So the output of this function is going to be an instance of an express router. So with that knowledge, we can just go ahead and delete everything that we've been working on here and remove all this code. And the idea is that this setup routes function is going to be a nice and clean, simple function. And I'm going to also, and we'll just remove this high level router that we created there. And so what I'm trying to say is that we're going to have a variable here called router, and then we'll just assign whatever comes back from this root function to this router and then pass it onto our main instance of Express. And you'll see as soon as we've made these changes, we're getting an error in our terminal here. And that's just complaining that the router that we're attaching onto the Express instance hasn't got any middleware registered to it. So that's because we haven't implemented it yet. Our setup routes function is kind of all good to go. And in our index.js over here, we've got nothing set up, and this is kind of the problem. And so let's go ahead and implement this. We'll just say import Express from Express. And then underneath the console log here, we can create an instance of router from Express there. So we'll say constant router equals Express. Then we'll just instantiate a new router. And this is where we can register a piece of middleware. We can use the router.use, and we'll reference a / there. We'll just pass a request handler, and we'll just send back a status of 200 to end that cycle. And let's just put a console log in here. Say heading index.js router middleware. The last thing we need to do, once we've attached that middleware onto the router, we can then return this instance of router from this function. And in that way, you'll see as soon as I hit save here, in our terminal, we get the green lights again. Everything's working fine. There's no more errors. We don't have to worry about that. And so the return value of this root function that gets invoked here is an instance of an Express router. It's assigned to this constant. It's then attached onto the main Express instance. So I know this is a bit repetitive, but I think understanding this and in the way that we've gone through it, I think you're going to have a very good understanding of how this all works. We can test this now because we've kind of restructured our code a bit. Let's go back to Postman and test this out. All we need to do is test the base path of our API here. And if I hit send, you'll see I get a 200 OK. And you'll see we get that console log saying that hitting the index.js middleware function. So it's looking good. We're moving in the right direction. The last piece of the puzzle now is, you might be wondering, what's the point of this index.js? I've already said it's to aggregate all the different subrouters. And so we haven't got a subrouter yet, but let's go ahead and create one. And this is going to be this default router that we've been talking about. So we'll create a file called defaults.js. And this file is going to be dedicated to housing all the specific routes for those generic type of routes that I was talking about. You can think of each file that we create here in the routes folder is going to be dedicated to a modularized router that we create. So we're going to set this up real quickly because we're quite familiar with the syntax now. So we'll just go through this real quickly. We're going to import Express from Express. We're going to create a instance of the router, and this is where we can name the router like the high level name, and in this case this is going to be the default router. So we'll assign that the value of an instance of router, and then we'll go ahead and create a function that we can export here, and we'll just call this default route, and that's going to be an ES6 arrow function that we can make use of. All right, and then we can just reference the default router. Let's just create this get here, and we'll just create this ping endpoint that we've used before, and we're going to set up our request handler, and then we'll need to grab a hold of the request and the response, and let's put a simple console log in here. We'll say default router, and we'll say get ping handler, and then we'll just send a status of res.send status, and that'll be 200. And so this is great. In this file, we've got a modularized router, this default router. It attaches one piece of middleware, but at this point, it's not returning anything, or it's in isolation. So we need to think of a way, how can we attach that default router onto this main router that we've created here in our index.js. The way that we're going to do this is we're going to make use of some dependency injection. So I'm going to just remove this router.use function. In addition to that, I'm just going to remove this console log just to clean up our code a bit. Now, the way that we can attach our default router onto this main router is, like I said, we can use dependency injection. So what we can do is import the default route. So we'll say import default routes, and that's going to be that function that comes from this defaults.js file. So we can just reference defaults.js, and then once we've imported that, we can reference this function, and then we can pass through the instance of this router. So this is the main router that is being attached onto the Express instance. So we'll just pass that into this function. And now we just need to adjust the function to make sure that it takes in the router. At the top of this function block now, we can just say router.use. So this is the router that's being injected in. The default handler is going to just be on the base path of the API. So anything that comes from the after API will be routed through this middleware, or then we'll just attach this whole default router onto the main router. In that way, this function will do the work of attaching the default middleware onto this router, which then gets returned from this function, which then gets attached to the instance of our Express API. So let's just go ahead and verify that we can actually hit this ping endpoint now. In Postman, we can hit a send here. We get a 404 not found because we've got no path that will match like the base, just the simple base of our API. But if we now reference the ping endpoint and I hit send now, you'll see you get back the 200 OK, and you'll see we get that default router get ping handler console log has been hit. So this is really great news. We've done a lot of work to get to this point where we've got a lot of different moving parts now, but it's going to really pay off in the long run. You'll see later in the course when we're creating the router for this is going to be nice and neat, a nice, simple, easy way to do it. With that last Postman request, we've successfully hit this ping endpoint here. So the last thing I wanted to do just to kind of tie this all together is do a walkthrough from the top down. And then I just want to put some console logs as we go along. and then we'll do another test, and we're going to see the flow of how the request comes in through our application middleware now. So let's start all the way at the top at our server.js. This is the entry point of our server. This is where the express.listen function gets invoked, and any middleware that we create here then also gets attached to the express server. And the way this happens is with our setup routes function. Let's go and just put a simple console log here, because this is kind of the first step in the process. We're going to label this number 1, and we're going to just say attempting to set up app routes. And if I hit save here, we do see that that console log appears here already. And then so let's go ahead and we'll step into the setup routes function. So once we're in this folder, the setup routes function is going to be dedicated to creating a main high level router. And so we'll put a console log here, and we'll just say initializing the main app router. You'll see if we hit save there, we start seeing the sequence of how this works. And then so what's happening once the main router is initialized, how this works is it calls this routes function, and when this gets invoked, we can just go into this index.js file of the routes, and this is the function that does the work. And then what's happening in here is we can put a console log, and it kind of write out that in this function is what it's doing is initializing the individual app routers. And so what's going to happen in this file is for every sub router that we create in our application, it'll be invoked with a function. So down the line, when we have a user route, we'll have the same thing here, where we'll just create invoke functions to set up each and every set of routes. So for now, we can just click save, or we can hit save here, and you'll see that we get our third console log in the sequence there. So we're flowing through the server to the setup routes into the index.js here, and then lastly, like the bottom layer of this whole sequence is in our default routes. We can create a console log here. We'll say initializing default routes. We've gone through the server, setup routes, index.js, the default.js here. And so that's how this middleware is kind of being registered as our app starts up. And then just to kind of go back to this setup routes function here, right after this routes function has been invoked, we can create another console log. And the fifth step here will be the mounting of the main router onto the express instance. Now you can start seeing the order of how this is all working. When the server starts up, it attempts to set up the routes. It creates the main router. It sets up individual routers, which then attach individual routes onto the high-level router. Once that's done, everything returns, and it then attaches the main router onto our express instance. And then the last step is in our server.js file. We can just put a console log here saying the app route setup is complete. And if I hit save there, you'll see that is indeed the last step in the middleware chain there. With everything that we've set up there, we've got a really cool mechanism of setting up our app router in a very modularized and a very clean way. We've taken this very step-by-step incrementally. The reason why I chose to do this is to make sure that you can understand in a very deep way how exactly this express router works and the concept of the middleware chain that it uses. So that's a wrap for this lesson. We've done the bulk of the work for most of the module now. There's just a few tweaks we want to make. I think in the next lesson, we're going to work in that default router and implement some more of our default routes. And after that, we'll take a look at some configuration and environment variables that we want to use with our router. For now, let's take a short break. I'll see you in the next lesson. Cheers for now. The main routing mechanism for our Express API is now set up. We've put everything in place. We've done a lot of work to understand this in a great amount of detail. To move on and start finishing up this module, the last step is to go ahead and implement some specific routes in that new default route handler that we created. And so let's get started straight away in Visual Studio Code. Let's just go ahead and head on over to our default.js file. And this is going to be the file that will house any routes that we want to create and attach to this default router. So we started off with a very basic ping endpoint that we created. Let's just go ahead and clean this up a bit and then put it in a format that will be better suited to our API. The first thing I want to do here is just adjust this console log. I'm just going to format the string in a bit of a nice way. We'll say hitting the ping handler. And let's just use some string interpolation here. We're going to grab a hold of the request URL. We'll send through a timestamp. Right, and the next step is we can just structure our response in a better way. So we'll say res.status, and we'll send back a 200, but this time we'll send back a JSON payload. We'll open up that object. We'll have a key with a code, which will just be a 200, and we'll have a key for a message. This will be a string, and we'll just say pong test successful. And once we've implemented that, we can go ahead and test that in Postman. You can just go ahead and initiate a request to the API/ping endpoint, and let's go ahead and send that through. We get our 200 with our nicely formatted JSON payload, and we can see our console log is being returned in our terminal. That's all we need to do for our ping handler. Now that that's set up, we can just go ahead and start writing out some more request handlers that we want in our API here. The next thing I want to do, and this is also just to kind of show you how you can do this. If you want to lock a specific endpoint to a specific method, so for example, we only want to allow the method get on the ping endpoint, we can create a response that will return a 405 method not allowed on this endpoint by doing a default router.all. And so basically what we're doing here is we're registering this piece of middleware on the get method, and that's matched to the ping endpoint. And so any HTTP request that comes through that match these two criteria will hit this endpoint. But if there's a post or a put or whatever that gets sent through, it'll skip this request handler and it'll just move on to the next one in the chain. And then we can kind of catch that request that comes through. So we'll say all other methods, then we'll set up a request handler. And I'll just set up a constant here. We'll say constant code, and this is going to be a 405. So the HTTP status code 405 for method not allowed. Then we'll just go ahead and we'll say res.status, and that'll be the code that we can pass in here. Then we'll just say JSON. We'll open up a JSON there to send back some JSON, and we'll send back the code as well as a message. And then we can use some string interpolation. We can get the method from the request. So we'll say rec.method. We'll say method is not allowed for this route. And then we can grab a hold of that route by saying rec.url. And let's go ahead and save our work and test this in Postman. So if we do a get request to ping, we'll see that 200 coming back. But if we change this to a post, you'll see that we get back that 405 method not allowed, as well as the JSON that we're sending back saying the post method is not allowed for the route ping. And if we test any other methods here, so that's the put or the patch, you can see that we're successfully achieving this result of we don't allow any other methods on that other than the get request, which will work fine. Okay, great. And the last default route that I want to set up, and we have worked with this before, it's that 404 not found. This is going to be the catch-all middleware that we set up for a whole entire API. If we send through a request that doesn't get matched up with any one of our request handlers, this is the middleware that we want to hit. So we'll set this up. We'll say default router, and we'll use the all method again, and then we're just going to pass in that wildcard, which is just the star character. And then we'll have the request and the response. We'll set up a code again, and this time it'll be a 404, and then we will say res.status. We'll pass in the code. We'll send back some JSON with the code and a message, and this message we'll just reference the URL, and we'll just say not found. I'm going to go ahead and save our work. We can head on over to Postman and test this out. So if we do an API ping, that's fine. If we send through an API/user, for example, and I hit send, you'll see we get that 404 not found with the correctly formatted JSON. You can try and send through anything here, and it'll be the catch-all for us. So just two things to take note of. If you leave out the API and you click the send here, you're going to get the 404 not found, and this is the default express error that gets sent back, and that's because any of our API routes are now only mounted onto that API prefix. So our code and our request handlers will only ever be available at anything after the API or /API. And so anything other than here, other than the ping, we'll get a 404. So that's pretty simple stuff. That's all that we're going to implement for our default router for now. Let's take a short break here, and in the next lesson and the last lesson of this module, we're just going to wire up some configuration in terms of environment variables and inject that into our routing mechanism. So I'll see you in the next lesson where we'll pick that up. Cheers for now. There's one last little piece of work that I want to do to finish off the work for our router before we move on to the next task in our API. And if we head on back over to our setup routes function, and before we start implementing any of the configuration or environment variables, I want to just do a little bit of code cleanup here. These console logs that were explaining to us the sequence of middleware in our Express router, that was just like kind of for understanding. I just want to remove that out because it's kind of making a mess in our code as well as in our terminal. So I'm just going to go ahead and delete those console logs. So I'll just go into all of the files where we had that and we can remove them. And the last place is just here in our server.js file. And just once you remove that, make sure that your API is still running and there are no errors in your console. And so now that we've done that, we can head on over to the setup routes.js file. And there's an additional piece of code cleanup that we can do. We imported Express at the top of this file when we were kind of iterating over our Express router. But when we refactored our code, we now getting the router from this routes function. So we actually don't need Express in here anymore. So we can just go ahead and remove that. In terms of what we want to do with our environment variables, we've hard-coded this string into the app.use over here. And I actually want to save this and store it in our application configuration so that we have that in a nice neat space where we can change that if need be. So we can just go ahead to our config.js file, and in our object that we export here, we can just go ahead and create some additional configuration. So I'm just going to leave a comment here, and I'm going to just put a comment here just letting us know that this is the REST API config, and we'll have a key here for API. We'll give that an object, and we'll have a sub key in here called the prefix. And this will just be the prefix that we set for our whole entire API. And for now, we've been using this API. And so we can just move that into this object here. And I'm going to go ahead and save our work. Back in the setup routes at the top of the file, we can go ahead and import our config. And that'll be from the config file that is in the same directory. Now that we have a reference to that config, we can just say config.api.prefix, and in that way we don't have that hard-coded string. Save your work in your API and just make sure, just do a quick test to see if the API is still working, and it is working in the way that we expect. That's all looking good. So that was the first little minor change I wanted to make. And there's a second change I want to make with our configuration. If we head on over to our routes folder and in the index.js file, and this is the file that's going to aggregate all the subrouters that we create in our application. Eventually, this can be quite a long list of different routers that we create, whether it's a user router or an account router and anything like that. So when we're going through the design of our API, I was talking about wanting to implement this ability to toggle different routers on and off within our API. And the way that we can do that is we can set up some conditional logic, and let's just say I'll hard code the value of true in here, and just so that the expression passes. And we can just have this very simple mechanism where we can surround each router with a conditional block, and then we can say if the expression is true, so if this router is enabled, then we can invoke this function, and then that's going to attach all the middleware onto our main router. And so for every different router that we have, eventually we could have this mechanism where we can just say only attach those routes onto the API if they've been enabled. So it's a cool mechanism to just toggle this off and on at a high level. And so now that if I save my work here and we've hard-coded this value of true, in Postman we can still test this and we can see our API is functioning just as it should be. But if we had to simply reverse this logic and say, put in something false here, so if we did if not true, which is kind of simulating a false condition, if we had to test out our API now, you'll see that we get this 404 not found. And this is the generic Express error that we're getting. So none of our routes on our default are available anymore because they actually haven't been attached to the express router. This just gives you a mechanism down the line if you wanted to disable and enable whole sections of routes, maybe for safety reasons or for testing in your configuration. If we have a way to kind of tie this up to our configuration, we can just set this in one file in our JavaScript code, and then we can just ensure that none of these routes ever get attached onto the express router. So the way we can do this is if we head on over to our config.js file, and right underneath the API section here, I'm going to create a new comment, and I'll just create a comment here. We'll say switch routes on or off, and we can do that by creating a key here called route, and it'll be an object, and then we'll just have a key for every that relates to every one of our routers. At the moment we only have this one router, the default one, and we'll just enable that to true. And once you're done with that, we can go ahead, we can import our configuration from, we'll go back one level to the lib folder, and then we'll find that config.js file, and then once we have the config there, we can say config.routes.default, and if that is set to true, then we will attach all those routes to the router. And now with that we set up, we've got our API default routes that are responding correctly now. If we do a GET request, you'll see that we get this 200, and now the routes have been enabled. So now we have a really neat way to control this just from one config file, and that's a really cool mechanism that will become useful as your API grows bigger and bigger. Alrighty, so with that last piece of work that we've implemented with our configuration and the ability to toggle routes on and off at a higher level, we've now finished all our work for our express router that we've set up. Again, well done on making it this far. Let me know if you have any questions. We did go through quite a lot conceptually, as well as going through quite a bit of a process to get this all set up. But I thought that this was the best way to kind of explain it in a way that will, by the time you reach this end lesson, you understand exactly in detail how the express router works and how the mechanism that we've set it up in our code is a nice and efficient, clean way to do it. And so let me know what you think. That's a wrap for this module. I'll see you in the next one. Cheers for now. Module 8 is going to be all about setting up a MongoDB driver in our Express API. And as always, let's just take a quick look at what we want to try achieve by the end of this module. The high level end goal here is to get a MongoDB driver set up, and that's going to mean a few things. The first one is to introduce a new initializer function into our application, which we can make use of. And so that's where we're going to add our setup of our MongoDB. We're also going to need to add some configuration and environment variables for our MongoDB driver. We're going to have to install a new package called Mongoose, which we're going to have to make use of. We'll then have to implement the actual code in order to get that Mongoose connection sorted to our Mongo database. And we'll also have to update our Docker Compose file to isolate and create a custom network that we can use. And there's just one more feature that we need to add onto our Docker Compose file once we have that driver set up. The last two things here is just to introduce some refactors into our code base. So we will then abstract, and then we'll move our setup routes into the initializers that we'll set up, and then one or two code cleanup and tweaks as we go along. So that's what we're going to try to achieve in this module. We'll get started in the very next lesson, so I'll see you on over there. Cheers for now. Let's begin doing the work to set up all the components, files, and folders that we need to implement this MongoDB driver. And the first task for us is going to be setting up or doing some scaffolding and just getting the different pieces that we need into our Express API. So head on over to Visual Studio Code, make sure that your containers are up and running and we're ready to go. And if your containers are running, let's get started. The first thing I want to do is in our lib folder, I want to go ahead and create a new folder here. So this is going to be a subdirectory within the lib folder, and we're going to call this initializers. And the idea with this folder is it's going to house any files that we write that are going to be dedicated to initializing certain software or databases or anything like that. So this will be a good place for us to store our MongoDB driver. Before we do that, let's create an index.js file. This will act as the root file in this folder that we want to export, so that just to account for if we have multiple different services that we want to initialize, we can just kind of aggregate them in this file and then export it in one go. Before we start writing any code, let's just create one more file here, and this is going to be mongo.js, and this file is going to be dedicated to creating our MongoDB driver. Let's begin our work here in the index.js file. I'm going to create a to-do here, and we're going to import the setup Mongo function. And so this is something that we still need to create, but it's just a reminder for us to do it once we've written the actual code to do that. And so this index.js file is going to export one function. We'll set that up by saying export const initialize app. And so this will be an arrow function. I want this function to take in two arguments. The first one is going to be the app, so that I want this to be the instance of Express that we've created in our server.js file. And the second one is I want to inject the whole config object into this function so that we've got that available, which we will need once we've implemented the setup Mongo function, as well as any other initializers that we write down the line. We can then just inject the config into those functions so that they have access to the environment variables that they will need. Now that we have this function block scoped here, we can just create a comment here, and let's just say the first step here is to initialize MongoDB. Obviously this code hasn't been written yet, but for now let's just do a console log. What I want to do here is just test that this file is connected correctly. So we'll just for now say MongoDB setup and connected. Once we've got this console log set up here, let's just head on over to our server.js file. Let's go ahead and import this function that we've just created. So we'll import initialize app. This will be from the new initialize folder that we've created. So it'll be initializers.index.js. Once we have that function imported, right after the setup root here, we're just going to say initialize app. And then we're going to pass in the HTTP server, as well as the config. And then I'm just going to hit save there. And when I hit save, you're going to see that we do get this console log out here into our terminal. And so that we know that this now is connected and that export function is working correctly. And before we move on, I just wanted to do two quick refactors here. One change that I want to make to our server at this stage is instead of this constant being called HTTP server, I actually want to just rename it to applicate or app here. We're going to go ahead and rename every instance of HTTP server, and then we're just going to change that to app. And so it's just in these 4 places that we need to change that. Just hit save and make sure there are no errors or anything like that. And I think that's just going to be a bit more clean, a bit more concise, and it's going to match up with the way that we've been writing our initializers and our setup routes and all of that. The second thing is I know that this initialize app is going to be an asynchronous process, especially with something like setting up MongoDB. It could take a while to set that up. So what we want to do is just add the wait keyword here. And in order to do that in the correct way, we need to make sure that this outer function is marked as async. So just go ahead and mark that as async, and then we've got the wait here. And then the last thing we need to do there, just make sure your work is saved. And in the index.js, we also just want to mark our function here as async. With those two changes, I think our index.js has been set up correctly here. And let's go ahead and implement this setup Mongo function. So in your mongo.js file, you can just open that up. And let's open up an export function block here. We're going to say export const. We'll say setup Mongo. And this will be an arrow function that we export. And in order to set up Mongo, as we'll see in a couple of lessons time, we're going to need some environment variables. And in our index.js, we've got this config object, which is imported from here. That config will be passed through to the initialize app function. And when we invoke the setup Mongo function, we can just pass that config through. And so I'm going to just use some destructuring here. And I'm going to preemptively destructure a key that we're going to add to our config in a moment called Mongo, and then we'll have access to all the Mongo variables that we need to set up Mongo. Before we actually write the code to do that, let's just go ahead and write a console log here. We're going to say testing mongo.js file. I'm going to go ahead and save that. The last step to wire this up is just to implement this to-do that we had over here. We can say import setup Mongo, and that will be from the MongoJS file. I'm going to hit save, and once we've imported it, we can just go to this comment here. We said initialize MongoDB, and we can just invoke the setup Mongo function. We want to pass through the config, and then I'm just going to go ahead and hit save, and you should see our console log here testing MongoJS file, and that validates that our work that we've done to scaffold out our initializer here for MongoDB has been set up correctly, and everything's wired together to our main Express server. We've got that scaffolding set up now to go ahead and start implementing the actual code to set up this MongoDB MongoDB driver. So let's take a short break here. In the next lesson, we'll look at installing Mongoose. So I'll see you on over there. Cheers for now. Hello and welcome back. We're about to install a new npm package into our Express server. In order to set up a MongoDB driver into our Express API, so we have a very convenient and efficient way to work with the actual MongoDB instance that we have up and running. We're going to make use of and leverage an npm package called Mongoose, and this works very well with MongoDB in the Node.js world. If you head on over to npm and search for a package called Mongoose, you'll see this page that comes up, and at the time of the recording we're on version 8.0.4, and you can just take a look at this page and just see how many downloads there's been, any open issues, the collaborators, and when last there's something that was last published. So you can see this is very well supported, well used package. You can just scroll through here and take a look at some of the documentation. I'm just going to go and click on the actual homepage of Mongoose, and we can just read the docs here, and you can see there's some boilerplate code examples here of how to connect to a MongoDB instance using Mongoose. It's pretty simple. We just, from a cursory glance, we just have to construct a URI that we can then connect to and just pass some information through that. You can go ahead and read this in more detail, but we're going to walk through how we're going to set this up step by step right now. The main takeaway from those docs is just to see that we're going to need to set up some environment variables for our Express server to construct and build up that MongoDB URI. The first thing that we're going to need to do is go ahead and kill your container or your containers. I'm just going to clear out some more space here. What I want to do is I'm going to change directory into our API folder, and once we are in there, we're going to do an npm install, and we're going to install Mongoose. And this is just going to go ahead and install the package from npm and add that package to our package.json file in our Express server. And once that's done and installed, you can just verify that we have this Mongoose key and value for the version that's been added to your package.json. And so to make sure that this is all working correctly, even though we have volume mounting set up, whenever we introduce a new package, we want to just rebuild the image. So once you've installed Mongoose into the API, we can just change directory back into the node docker mongo directory, which is the root of our project. So to do that, we can say docker compose build, and then we'll just say reference API, so it'll just build that specific image for the API, and it doesn't have to worry about the Mongo definition. It's going to go ahead and hit enter there. And so the reason we're doing this is so that this new package then will be installed when this Docker file is executed, so that when it copies over this package.json, it's got the instruction to install Mongoose. Once the image has been built, you can just say docker compose up. Your container should now be running, and it should be run with or rerun with the newly built image that we've just created that contains Mongoose. And if everything's working correctly, I think we've successfully installed Mongoose. And so let's take a short break here. In the next lesson, we'll set up the configuration environment variables that we need in order to set up our Mongoose driver. So I'll see you on over there. Cheers for now. When we took a look at the Mongoose docs, we saw that in order to set up a connection to MongoDB, we do need to create a URI that contains a connection string of sorts. And so in order to do this, we want to make use of our environment variables and our configuration mechanism within our Express API. And the first step here is let's go ahead to the .env.development file that is in the root of your API, where we have our port defined. We're just going to go ahead and set up a few environment variables here. The first one is going to be Mongo, and the value of this is going to be MongoDB : //. Next up, we will have our Mongo URL, and this is going to be my app DB, and then this will be 27017. Next up, we need to do the MongoDB username, and this can be the same value as the admin account that you've set up over here for your Docker Compose file. And so we can just go ahead and reference Jack here, and then we'll say MongoDB password. That will be example 1234. And lastly, we just want to set up the MongoDB name, and that's going to be my app DB. Now that we've declared those environment variables, we can head on over to our config.js, and we can just create a JavaScript object that is going to link these conveniently up into our Express API. So we're going to create a new key here, and we're going to call this Mongo, and that's just going to be an object. And so we're just going to create the keys that we need here. We're going to set up a protocol, which will be available from the process.env.mongo protocol. Next up, we will have a username, which in the same way will be from process.env.mongo username. And then it's going to be the same thing for all these keys. We want to have a password. We'll have a database key, which will be a reference to the database name. That will be the MongoDB name. And lastly, we'll just have a URL key here, which will be the value of Mongo URL. With that object defined now, we should have all these variables now available to us in our Express API. And because we're importing our config into our server.js and we're passing that through into our initialize app, we should get a hold of it here as the config global object, and then in our mongo.js file we're destructuring that config and we're pulling off the Mongo key that we've just created. So let's just go ahead in here and add in a JSON.stringify, and we'll just print out the value of Mongo here, and let's just validate that those values are indeed being pulled through. So if we hit save here, you'll see in our console log we've now got this JavaScript object that has been printed out. It's got all the values that we need, and we can see there's no undefined or anything like that. All the keys look good, and hopefully no spelling mistakes or anything like that. But we'll test this out in a moment. But for now, we've got all the pieces that we need to start setting up the connection string and writing the actual code to set up Mongoose. So let's take a short break here. In the next lesson, we'll go about doing just that. So cheers for now. Hello and welcome back. We're at the point now, after doing some initial scaffolding and some setup with our configuration of our Express API, we can now go ahead and set up Mongoose with its connection string to MongoDB. And so in your mongo.js file, just go ahead and delete this console log now that we know that everything is set up and working correctly. The first thing that we want to do here is we want to import Mongoose from our npm packages. So we'll just say import Mongoose from Mongoose because we're going to need this in a moment. And now we can begin doing the work to start setting this up. The first thing I want to do is destructure some of the variables from this Mongo object. And this is going to contain the configuration items that we need. So we'll say const, and then we'll just open up the syntax there for destructuring. And so we're going to destructure the protocol, the username, password, database, as well as the URL, and that's going to come from this Mongo object that we're destructuring in the parameters. Now that we have a hold of the environment variables that we need from our Mongo object from the config, we can go ahead and use these values to create the connection string or the connection URI that we need for the Mongoose driver. We can go ahead and create this by saying const connection URI, and this is going to be a string that we're going to build up with our variables here. So we're going to use a template literal, and then we can just start injecting some of these values. So the first part of this connection URI will be the protocol, and then right after that, without any other characters or spaces, we're going to put in the username, and then the next part will be a colon, which would separate the username, and the next value here will be the password. But we need to encode this password in case there's any weird characters. We're going to use this encode URI component, which is available to us in JavaScript. And we're going to pass in the password into that function. After the password, we're going to use the @ sign here, which will then be followed by the URL that comes from our config. And after that, we'll have a /, and this will then be the value of our database name. So we'll just reference the database variable there. And then right after that, as like a query parameter, we want to put in this value here, auth source equals admin. And this is just a reference to the way that we've set up our MongoDB using a root admin account. With that, I think we've got the connection URI. There's quite a bit going on here. There's quite a bit that we've typed, and it's quite hard to read. So let's just go ahead and create a console log and dump this out to the console and see if we have made a mistake anywhere or if it's looking good. So I'm going to go ahead and save that. And you can see we get the value here. We have MongoDB, which is the protocol here. And then you see we have a value of undefined, which is probably looks like there's something wrong with the username. We've got the password, which looks good. We've got the database URL, which looks good. The name looks good. So everything looks like it's working fine except for the username. So let's just do a quick debug to see where we went wrong here. Doesn't look like I've made any spelling mistakes here. We can head on back to our environment file and just make sure we have MongoDB. So we have MongoDB username here and then Mongo password. And so this is just a mistake that I made. I can see I just added the prefix here, MongoDB username. So I'm just going to remove this so that it just says Mongo username. And once I save that, we can just go ahead back to our config. I did type out Mongo username over here, so that's all good. It was just a mistake in environment variables. And you can see if I just save some of our work in one of the files to reboot NodeMon, you'll see that the connection string now contains our username of Jack. So that's looking all good. Just a quick test to see if the URI is actually looking like it should be before we move on to the next step. So I'm going to go ahead and just tweak our console log a bit. I actually want to leave the console log in here for debugging purposes. It might be quite handy. So I'll create a template literal, and I'm just going to give us a space so this looks neat in the terminal output. And we can just say connection URI, and then we'll have a colon, and then we'll just inject the value of connection URI here. And so that just reads a little bit better here for us. And let's move on to the next part of doing this Mongoose connection. And now the last step here is to set up a try catch block. So we can just set up the catch block here first, and we can, if anything does go wrong here, we want to throw a hardcore error because the connection to the database is not working. So we can say throw new error. We'll just pass through the error that we get back. And in the try block here, what we want to do is reference Mongoose, and that's a package that we've imported here at the top of the file. And then it's got this function here called connect, and all we need to do is simply pass in the connection URI, which is the string that we've built up with all our config variables. And this is an asynchronous operation, so I'm going to mark this with the await keyword. And in order to use the await keyword, we need to mark this function as async. And with that, let's go ahead and save our work and see what happens. We're going to just hit save here, and you can see our server was restarted and there are no errors or anything like that. And due to the fact that there are no errors, we can safely assume that Mongo is now correctly set up and connected to this connection string. And now that it's connected, we've got our driver set up to MongoDB within our Express server, and we'll be able to start using and making use of all of the features that are available to us through Mongo. Right, so let's take a short break here. In the next lesson, we'll do some work to adjust our Docker Compose services. I'll see you on over there. Cheers for now. We've done the work to successfully implement the Mongoose driver, and it's all working correctly. There are a few more things that I want to do to round off this module. The first thing is if we head on over to our dockercompose.yaml file. Now that we've got our MongoDB and our Express API getting more sophisticated, I want to introduce a new bit of configuration to our Docker Compose YAML file. And at the same level as the services, I want to go ahead and create a networks key here, and just make sure that it's at the same level as the services here, not indented, otherwise you're going to run into some problems. And under the networks, I'm going to go ahead and create my app network, and then I'm going to just reference this key here, driver, and we're going to use the bridge, which is the default that Docker uses. Now that I've defined a custom network here, what I want to do is, instead of, at the moment, both our services, the Mongo service and the API service, is making use of the default network that is created by Docker and Docker Compose. I just want to go ahead and tell Docker that I want to create a custom network, and I want my services to be isolated within that network. So we can go ahead and we can just add this definition here to each service. So we'll say networks, and then we'll just reference the my app network. So we'll also do that in the API service here, and we'll reference that my app network. And there is one more change I want to make here to our Docker Compose file. Now that we've got MongoDB, an Express server, as well as in our Express server, we've got a driver that is waiting to connect to MongoDB. I want to add this key onto the API service here that makes reference to this depends on key. We'll tell the service that it should only be booted up once the dependent service that is dependent on is up and running correctly. So I'm just going to reference the Mongo service. And so all this is saying is this API service is dependent on the Mongo. So don't start up the API service until the Mongo has been successfully started. So it's going to clean that up a bit. And with those changes to our Docker Compose, I just want to go ahead and we can stop our containers. Before we restart our container, let's just do a Docker network ls, and you'll see that all the names are all the default bridges and networks that Docker have created. And if we go ahead now and say Docker Compose up, if you take a look at some of the output from the logs, you'll see that there's this new My App network that's been created, and you can see the API and the DB has been attached to those networks. And so in a new terminal window, you can just go ahead and do a Docker network, and you'll see that we've got this new network that has been created. And this is just a custom isolated network that I wanted to create for our services, a custom configuration that as your API grows and if you introduce new services, you can know for sure that all your services are networked on an isolated container. So that's the work that I wanted to do for the Docker Compose file. We've implemented those changes, so let's take a short break here. In the last lesson, we'll just do some minor refactors, and then we can call it a wrap for this module. So I'll see you on over there. Cheers for now. We've successfully set up our Mongoose driver. I'm happy with the work so far, barring one little refactor that I wanted to do. If we take a look at our code base now, we've introduced this initializers folder. We can use this initialize app function to import any other initialization or setup that we need to do. And to start off with, we've just added our setup Mongo function here, but it actually makes sense to move our setup routes function that we've created in the previous module and actually just abstract it into here, and so that it makes logical sense to contain all those kind of setup functions within this initialize app function. So the first thing to do is let's go to our server.js and let's just go and remove the setup routes import as well as the setup routes function invocation. And you can go ahead and save your work in your server.js file. Then the next thing that we need to do is now move our setup routes file into the initializers folder. So we can just go and you can just drag that in Visual Studio Code and confirm if you want to move that over. And just in Visual Studio Code, it automatically updates the paths to any imports that you have. Just make sure that these paths in your setup routes file is correct once you've moved the file into the initializers folder. And I'm going to go ahead and save that work. And then in the index.js, we can go ahead and import the setup routes function. And this will be imported from setup routes.js. So we can just create a comment here. We'll say setup express router. Then all we need to do is invoke the setup routes function. And this function takes in an instance of our express server. So we can just pass in the app here. And once we have that, we can just add a console log here. And we're going to say, we'll say express router and app routes complete or setup. We'll just add some ellipses to each one of these. And then one last little tweak here to our console logs. We're just going to make a minor adjustment here. I'm just going to add the same style as what we have in our other console logs. And if I hit save there, you'll see our console log says MongoDB is set up and connected. We've got our express router and the app route setup. And then the last step, the server is running. So you can see that we're starting to build up our own middleware chain in our Express API. And that's all happening at this line here, at line 10, where we initialize the app. And once all of that initialization is complete, only then does the server start listening on a specific port. So this can help you down the line if you've got multiple databases that you need to set up, if there's other initialization that you need to do to kind of add to your own middleware chain. And so I think our API is starting to take shape really well here. It's got quite a cool pattern that we've implemented here. It's an interesting way of setting this up. And with those minor refactors and tweaks that we've made to our code, I think that's a wrap for this module. I think we've set out and achieved what we needed to do. So I'll see you in the next one. Well done on making it this far. Let's keep going, and I'll see you in the next module where we will continue our work in our Express API and actually start using Mongoose and start using this Mongoose driver to implement user schemas, being able to set up some routes to be able to save some information to our database through our API. So I'll see you on over there. Cheers.